Hello YouTube and welcome to episode 3 of my C++ programming tutorial series right up here on YouTube. So, in today's episode we're going to be discussing control flow. But before we do that, if you remember in last episode I set you guys a challenge. I said create a program that asks the user for their name, their age and where they live, and then outputs that out into console. So, hopefully you actually tried this, because the best way to learn programming is to actually program. So it's all right. It's all right just watching YouTube videos on a subject, but in programming especially, you need to actually apply what you learn in the YouTube videos or whatever, and that's how the concepts really sink in, and you get a really deep understanding of them. So, with that being said, let's get into my solution. Hopefully you've got something similar, or even if you haven't, it doesn't matter as long as it does the same thing, because that's the beauty of programming. There are various different solutions that achieve the same exact result. So let's get into it. So I created 3 variables: name, address, age. Name and address are strings because obviously they're text. Age is I put as an integer because obviously it's a number. So these are what I'm going to store the user's input into, these separate variables. And then in this section, I asked the user for their name, output that to console, then I stored it. Remember this function, cin, we discussed it last episode, and how to get input from the user. So we're getting input from the user, storing it in the name variable, and then we're asking for the age. We're storing it in the age variable. We're asking where they live. We're storing it in the address variable. And then here we're outputting, all these variables into console, but we're doing it in sort of a nice little sort of conversational way. So, hello, name. You are age, years old, and live in address. Obviously, these are going to be replaced once, with whatever the user inputs. So, and, let's try it. Let's press F5 and run the code. So please enter your name. So we could say your name is whatever. It could be John. You could be 31 years old, and you could say you could live in London. So it will say, hello John, you are 31 years old and live in London. Brilliant. So hopefully you guys actually attempted this, and really I may set you some other challenges to attempt, just to help deepen your understanding. But anyway, let's get into today's topic. In fact, before we do that, there's something I would like to show you too, which is here where you see we have to specify obviously the namespace, which I discussed 2 episodes ago. That can get very, very tedious in larger programs. So what you could do is you could write something like using namespace standard semicolon, and then if you write this code, what would happen is it would check if there's no if you're not specifying the namespace. It would check the locally declared functions, and it will also check in the namespace automatically. It would just go there, so you don't have to specify the namespace. It would automatically check in that namespace for you, so that way you don't have to specify the namespace every single command. So if you see, if we do something like this, remove that and we just put cout, you see there's an error because we haven't specified the namespace. But if we specify the namespace up here, we're specifying the namespace for all of these commands, so this would actually work fine. You see, it works, the program runs fine. So we can actually do that for this function, this. Oh, don't want to take that out, but we can actually remove all of this. And this actually works fine. See? And we can even remove, declaring the namespace for the strings too. We don't need to specify namespace now. Now, this is, this makes your code look a lot cleaner in my opinion, but it does have some downsides in larger programs, especially where you may be using multiple namespaces, or you may have other functions with this, named cout or another variables. It could be anything. But if that's the case, for example, if we create a function called void cout, there's error. There's an error here. Why? Because it's a naming collision. Cout is ambiguous because is cout referring to the cout within the standard namespace, or is it referring to that function? That's why this could be a bad command, or a bad sort of line of code to have in your program, because if we remove this and we actually specify the namespace, they're no longer ambiguous, because now we know you are referring to the standard namespace. You're referring to the cin or cout command in the standard namespace, and you are not referring to this cout function, because if you're referring to this cout function, you wouldn't include the namespace. You would just put cout because it's not in a namespace. So that's why you can have the using namespace standard line of code in your program, but just beware, or in complex programs you may, it's kind of bad programming practice, because you can open yourself up to sort of naming collisions, etc. Anyway, so now let's get into some control flow. Control flow allows, like I said, in certain instances where you would only want a certain lines of code to run if certain conditions are met. This is where control flow comes in, and let me just show you what that looks like. If, then in parentheses we put the condition or statement that gets evaluated to see if it's true. If it's true, the block of code gets executed. If it's false, then the block of code gets skipped and ignored. So we could say if age double equals, so equals to 18. Now we're using the double equals to say is age equal to 18. If it was a single equals, we would be saying age equals 18. So we're assigning the value 18 to age. But if we're saying double equals, we're making the comparison. So if is age equal to 18, this will resolve as true. So if true, so then it would execute the block of code. So that's if we have the value of obviously 18 within age. And then we put in the curly braces. This is like sort of where the block of code goes, like we have in the main statement. This is these two curly braces represent all the code within the main statement. These two curly braces inside here represents all the code within the if statement. So we could say, output, you are 18 years old. And we could run this, but first of all we might want to fix these. And if I press F5 to run our program, please enter your name. We could say John. We could say enter your age. We could say 18. Where do you live? London. It executes that line of code. You are 18 years old. But if we put our age as 19, so you could say John, 19, London. Hello, John. You are 19 years old, live in London. It doesn't print out that code after. So that's how if statements work. And to show it again, John, 18 and London. You can see it now prints out that because, that condition is true, so that block of code gets executed. So we can also use something called an else if, which looks like this. Now we're saying else if. So if this isn't true, then we resolve this statement. So if age is equal to 18, it would ignore the statement completely and just like move on. But if this is false, it would then consider the statement. So we could say else if age, is greater than 18. We could then, in curly braces, obviously representing the block of code we want to execute, we could output you are older than 18. So now, obviously, if age is 18, it won't even consider this block of code. It would just move on to the next. So if we run that, John, we could enter our name as 19, or our age is 19, sorry, and we live in London. It says you are older than 18. But to show you something, if we just use equals 18, so we got equals, you would see, like, if we enter our age as 18, you are 18 years old, but it doesn't print out you are older than 18, even though this condition is met. Because the first condition is met, it doesn't even evaluate this condition because that's what an else if is. But if we change that to if, it's going to evaluate both of them because an if is going to get evaluated no matter what. So if age is equal to 18, true. If age is equal to 18, true. So it would execute both these blocks of code. So if we enter our name as, we could just say R, we could say 18, we could say L. See, you are 18 years old, you are older than 18. But remember, if it's an else if the if statement above it is true, then it doesn't even consider this statement. So that's an important distinction to make between if and else if, obviously. We then have what's called an else statement. And an else statement is basically saying if all the preceding ifs and else statements are false, then execute this block of code. So this doesn't, the else statement doesn't have a condition. Well, the only condition it has is that all these are false. So we could say you are younger than 18. So we don't even have to make an evaluation, say is age less than 18. We can just say, you know, you are younger than 18, because if age isn't equal to 18 and age isn't greater than 18, then obviously it's less than 18, because what else could it be? So we can print this out. So if we just do 19 as an input, we could say you are older than 18. If we have 18 as our input, we could say you are 18, and if we have, say, 17 as an input, you are younger than 18. So that's some basic control flow, which is really useful to know, because this gives you don't want your program to execute or run the same way every time. Like in games, people make decisions. You want different code to execute upon those decisions, say. So you are 18, you are older than 18, you are younger than 18. Okay, so an important thing to know with if statements is there's various different operators you can use to, you know, make your sort of evaluation. So you could say not equals to, so if age is not equals to 18, so this statement will be true if you input anything other than 18. So we could say R, input your age, 312, where do you live, just L. See, you are 18 years old, because this statement is resolved as true because we inputted any value other than 18, so it outputs this, you are 18 years old. And if you can see, if we input our age as 18, it would say you are younger than 18. Well, why is that? Because if age is not equal to 18, we inputted 18, so that's false. Is age greater than 18? Well, that's false. It is equal to 18, so we're outputting by default you are younger than 18, because remember, if these two are false, the else statement gets outputted, or the else block of code gets outputted, or run, I should say. So that's an important thing to keep in mind. There's also, you know, you can have greater and equals to, or less than and equals to, or equals to, I should say, sorry. And these statements get evaluated, say, if, you know, age is greater than or equal to 18, so it could be 18 or greater, or you could have, like, you know, 18 or less, and certain statements will get evaluated. So there's many different operators you can, you know, to learn and apply to your programs. I suggest you know, just Google them if you want to get the complete list of different operators you can use, but we're not going to go through all of them here. So anyway, now we've done if else if and else statements, we can do some loops. So loops are very useful if you want to, you know, run through a certain block of code more than once. You don't want to write, if you wanted to run a piece of code 10 times, why would you want to rewrite that 10 times when you could just put it in a loop, which would just basically loop that code for you, so you only have to write the code once and you can run it as many times as you want. Code reusability is an important part of programming. Efficiency is important. So if you need to write, you know, if you need to run a certain bit of code more than once, either put it in a loop or in a function or something, which I'll get into a later point. But for now, we're going to talk about loops. So there's many different types of loops. We could have a while loop, which is represented by the while command. And in here is the condition that is checked. is evaluated, sorry, and then within the curly braces is the block of code we execute or looping essentially. So we could say, so if we like, you know, take an input for the user and store it into name, we could say while name is equal to r, or just lowercase r, we you know, get an input from the user name. I know we input okay, we'll just put like, you know, just an example, and this is an example of a loop. So let's run this quickly. So just, you know, we can do whatever, we can just, so okay r, okay r, okay r, okay r, okay r. Okay, this is keep getting looped because it's going, okay, name is equal to r, yes, okay. Let's take another input from the user. I input r. Okay, it checks it again. Name is equal to r. That is still true. So it outputs this again, or this block of code gets another input from the user. And it's going to keep doing that until we input something else like g. Now it exits because it goes, okay, we store the value g into name. Okay, is name equal to r? No, it's equal to g. So this is false. So now we're out of the loop. You could also create what's called an infinite loop, where you have a condition which is always going to be true. So if we say while true, that's always going to be true. What true is always going to be true. That is just how it is. So this is always going to get this is going to keep on repeating because it's going to say, is true equal to true? Yes, it is. Okay, print out okay. Is true equal to true? Yes, it is. Okay, print out okay. Is true equal to true? Okay, it is. Print out okay. It's going to keep on repeating that. So we can press F5 and run our code. We can just input. Oh, yeah. You see, we get. It's going to keep on. It's going to keep on just printing out okay because that's an infinite loop, and you've got to be wary of them because you may accidentally create infinite loops, and it causes issues like that. So. Just make sure that there's, in while loops, there's a possibility of, you know, making a state where the actual condition you're evaluating is not true. Otherwise, it's just going to loop continuously. So we also have something called like a do while loop. So we can have do and then a condition. So we could say, okay, we could just print out okay in this example. And then we could say like while, and then the condition we're evaluating. This is really useful in situations where we want to, you know, run a certain block of code once, no matter what, and then we want to evaluate whether a certain condition is met. So we could do something like, you know, name is equal to r. So if we enter our name, age, and we could just say where we live, that's going to keep on looping because while name is equal to r, our name is equal to r. But if we input a name other than r, so double r maybe, input our age, input our location, it's going to say okay once because this is going to run once no matter what. Then it's going to evaluate, is this name equals, does the name equal r, sorry? It doesn't equal r, so it's not going to loop it again. So that's what a do while loop does. It executes a certain block of code if and only if a condition is met, but it would always run it once. Okay, now we have what's called a for loop. For loops are probably the most useful type of loop in programming, I would say. You're probably going to be using for loops more than any other type of loop, and they allow you to create, first of all, you have three fields in a for loop. You have something you can initialize, or like the thing when you first start the loop, something you can do. So we could say int I equals 0. So at the start of the loop, we are creating a new variable called I, setting it to 0. We then have another field, which is the what we're evaluating, what we are checking to see is true. So we could say why I is say, why I is less than anything. We could say 5 or less than or equal to 5, sorry. And then we have another field which is, okay, after this loop has been run once, what do we do? And in this final field, we are basically saying, okay, what do we do after this has been run once? We could say, plus plus I. And if you don't know what plus plus means, that just means increment. So we're increasing I by 1. You can do that in, with age. You could say, please enter your age, sin age. Then we could say, we can increment age. And if we run this, sorry, I've got to obviously make the curly braces. So if we input 18 as our age, where do we live? It would say, well, of course, we've got this OK loop going. We might want to remove that first. R18L. It says you are 19 years old because this double plus just increments the value by 1. So obviously 18 plus 1 is 19, so it's going to output 19. So that's what we're doing. We're essentially, so you can see by just looking at this is going to run about 5 times because we're just, I is 0. We're basically outputting whatever this is because we're checking if it's less than or equal to 5. That it's, once this is run once, it's going to increment so I is now equal to 1, it runs it again, I is now equal to 2, runs again, I is now equal to 3, runs again, I is now equal to 4, until I is no longer less than or equal to 5. So we could do something like output, if we just output I, and then we'll end the line, it should print out 0, 1, 2, 3, 4. So if we just go 0, 1, 2, 3, 4, 5, sorry. So you can see that's been run several times, but once I is no longer less than or equal to 5, it stops running the code. So that's basically how loops work, and they're incredibly useful for just reusing code, because imagine you wanted to run a certain block of code, in a game, maybe you want every frame of that game, you want to run a certain bit of code. Well, you don't want to have to write that 60 times for every, just to run that 60 times in 1 second. That's just going to be awkward as hell. So you just use a loop to loop a certain block of code you want to keep on running or executing, and it will just make your code so much more efficient. And there's certain things that you're going to need loops for, which we'll get to at a later point. So that's everything for today's episode. Just play around with some looping, just conditional statements. Okay, for today's challenge, I would like you guys to create a program, a maths program actually, which will just ask you 10 maths questions, and you'll keep track of the score. So every time a user gets a question right, you'd add 1 to the score. And then at the end, you would, print out the user's score and maybe give them a grade. So you may say if they get 10 out of 10, they've got an A+. If it's 9 out of 10, it may just be an A or a B or whatever you want. So just do that and make that program. And in the next episode, I'll show you my solution and you'll see how ours differ. And we'll also cover another concept. So take care.